squared plus 2n is divisible by 6. Now, expression factors out as n plus 1, n plus 2. It's the product of 3 consecutive integers as well. One of the integers must be even, and one of the numbers must be divisible by 3. The expression therefore has 2 and 3 as prime factors. 2 and 3 as prime factors. And so the expression is divisible by 6. So you can just put that and say that this is divisible . But also what you can do is do proof by induction. So proof by induction is first we substitute 1 into this equation. So we are testing for 1. So 1 cubed plus 3 times 1 squared plus 2 times 1, which is equal to 6. And now we're going to test for k. K cubed plus 3k squared plus 2k, and let's just equal it to something like 6a, so we can match up what we did here. Now you might see where this is going. Next one is test for k. K plus 1. And here we'll just say k plus 1. We'll just put everything in brackets, substituting k plus 1 into n, and squared plus 2k plus 1, and let's just say this equals 6b. And what we can do here is just, what we can say, why we do this is just to say that each k we can test for a different variable. So if we test for a different variable, then it must be true for all different variables that are different to n. So we can just use another variable and substitute it in and see if we can prove the answer. So k we can just expand this out. And what that gives us is k two k plus 1 plus k cubed plus 2k k squared plus k. If you're having trouble with triple brackets, all you need to know is that all I did is just double brackets, which gives us k squared plus 2k plus 1, and I times by 1, and then I times by k as well, and then now I'm going to add those. And next is this thing here, which will give us 3k squared plus 6k plus 3 will give us 2k plus 2. Okay, so what do we have in? So, do we have a 6? Do we have our 3k's somewhere, 3k squared somewhere? So we do. We have a 3k squared. If we add 2k squared, 3k k squared together, get 3k. We also have 2k, also have k cubed. So let's just say all of this is 6a. All of that is 6a. Then we got remaining is 6a plus 3, 2 and 1, which is 6, and plus 3k squared plus 6. K plus 2k plus k, giving us 6a plus 6 plus 3k squared plus 9k. And the reason we do k plus 1 is we can substitute, is because we're trying to divide by 6. So if it's 6a, then we have to get as much numbers that are divisible 6 as we can. So if we assign this to 6a, this part is divisible by 6 as well. And now we're left with this part, which doesn't seem divisible by 6 at the surface, but we can work it out. So what we do here is we have to also simplify it further. So we've got 6a plus 6 here. Okay, and then we simplify it to 6a plus 6 plus 3k plus 3. Now 2c equals, let's say 2c equals k plus 3. Now we can say that 6a plus 6 plus 3 2c. The reason we do this is we want to get we want to get 6 exactly. So how do we get 6 exactly? Well, since this is already being multiplied by this value, we assign 2c towards it. So 2c would equal k plus k plus 3. Now this is going to be multiplied by 2c. And what's 3 times 2? Well, it's obviously going to be 6. So 6a plus 6 plus 6c is our answer. And we can divide everything by 6. Yes, divisible by 6. But giving us a plus 1 plus c. But we see here that we did all these steps. We assigned something to k, our answer for k, and we assigned something to our answer for k plus 1, and we just substitute 6a into it. And it's quite interesting because you can use these different methods depending on what the question asks you and what method is quicker. And this has been Hard Maths. Thank you for watching.